And are we pitching a traffic engineering trivia night at the road safety conference this year, Kim?
Well, funnily enough, you say that. We were just before COVID hit, we were in the midst of organising an international road safety barrier conference, and instead of a dinner, I was just going to run well, it was probably traffic engineering, road design, road safety trivia night, and we had so many good, exciting things going on. It's going to be great. And then COVID came along, but I do like the idea, Kathy. We'll put that over to the organising committee at the College of Road Safety there.
Yeah, we'll do. Okay. Session 4, the process. Serious business. Right. Let's go.
Well, it is, and let's jump into it. We've hit the record button. Okay, so there's a fair bit of documented guidance on how to do these safe system assessments. So there's some Austroads guidelines, and there's some jurisdictional supplementary guidance, and then we've got those fact sheets that we showed you. So we'll point you at all of that again, just so you've got that resource readily available. We're going to spend a fair bit of time unpacking how to complete the safe system assessment matrix. Some of you have probably played with that before, and that's great. Some of you may not have any idea what I'm talking about. Some of you may be scratching your head about why we're talking about the matrix and what that is, and isn't that a movie, not a safe system assessment thing, but we'll get into that. Then how do you actually write up a report? We want a consistent output of these safe system assessments going to clients, so it's a known process. They receive something they're sort of expecting the format of. Then we're going to spend some time practicing categorizing into primary or supporting. So when we make recommendations in a safe system assessment, we categorize. Now, those who have done the road safety audit course, you've recently with us, you've got some practice in this. But Austroads is really moving to starting to categorize road safety treatments or road interventions into these categories of primary or supporting. And so we've got to clarify that because we'll utilize it in the safe system assessment framework. So we did this nice look at this philosophy of the safe system. So reminded some of you of the philosophy of the safe system, and clarified a few points and got our heads around that. We talked about this diagram and all those wonderful principles New Zealand is operating under. We then sort of refined that into how does this play out in decisions on the road with infrastructure? Let's get some more clarity and decision-making ability from the sort of high-level principle-based stuff. And so then we started talking about this exposure, likelihood, and severity, and sort of delving into each of those and trying to understand how successful we've been. And in that severity one, we started to say, well, the biomechanics of injury are a really important thing in our design and operation decision-making within a transport network. So the amount of force we can take as humans, it's a critical design feature, which it hasn't really been as much in the past. And we brought up these diagrams, which people have seen quite a bit. And we started drawing lines around that 10% with that 30 km/h or below for pedestrian and cyclist crashes, or at the 50 for side impact crashes, and 70 or below for head-on crashes. And then if we want to operate areas with speeds higher than that, where those conflicts could occur, we've got to try to eliminate that conflict in one way or another. And then to make your life a little bit easier in the safe system assessment, I showed you this, but we'll be using this shortly to take these numbers out and use them for something in a scoring system for alignment with safe system principles. So we'll come back to this as well, but that's the severity aspect we're really honing in on. And then I did give you a lot of different things, because it's good to, yes, use that chart as guidance, but it's better to understand sort of the physics, the biomechanics of injury, crash types, general forces. So if you're thinking about crashes that may not appear in that list here, that you're able to sort of make some informed judgment on what the forces are going to be and how close they will be to within tolerance. So, you know, you might be thinking about cars crashing with trains, or e-scooters crashing with bikes, or you know, anything that's sort of not directly put in there, or even sort of sideswipe crashes and the like. So we've got some more of that, and there's quite a few different things. And I popped these all at the start of this session, just so they're easily there when you get into your safe system assessing, if you want to calibrate your biomechanics of injury assessment ability. Okay, but how do we do these safe system assessments? Well, Austroads came up with the Safe System Assessment Framework in 2016. This is the document, and like all Austroads documents, it's free. It's available on the Austroads website. You can download it, but we've put it into your learning management system so you can easily grab it. Now, I was on the working group for this. I wasn't one of the authors of it, but I was involved in a lot of the working group discussions. The project manager for it was Colin Brodie, a New Zealander that many of you probably know. And the whole purpose of this was to have this ability to see a project and give it a score or some sort of assessment or rating for its alignment with those principles that we've laid out. Now, before the release of this, there was a small group of us doing a thing called a safe system audit, and they took a lot of that and put it in there. There wasn't much interest in what we were doing back in those days, but they took some of that in there. But in that document, you see that there's a few things. There's some sections. Okay, there's what's the objective of this assessment, and what is the scale and depth of the assessment? Because we can do an assessment of an entire township or an entire community or an entire mine site, or we can do an individual intersection or piece of infrastructure or length of road. So, you know, what is the scale of that? And then what is the depth of our assessment going to be? You could do a safe system assessment that lasted months or years even if you wanted, or you can do something that's reasonably quick and provides you with a decent outcome. Now, general industry practice has fallen into a fairly nice mold in some of this, in how the depth that we're doing these assessments, and I'll take you through that. After that, the next section is around the context of the project. You know, what is the project objectives? What's the function of the road, the speed environment, movement in place categorization? What road users are we expecting with vehicles? You know, how does it all tie into existing stuff? You need to understand what they're planning to do and what the existing environment is, what the future visions are, in order to be able to predominantly make helpful recommendations when we get down to there. But some of it does feed into our ability to actually score things. And this is the next one, is this safe system assessment matrix, which talks about exposure, likelihood, and severity, and also other elements of the safe system, being the people, the vehicles, and post-crash care. And then some treatments, some recommendations, some alterations, and do they sort of transform in a primary sense our alignment with safe system principles, or are they, you know, moving us along a little bit as support? So I'm going to go through each of those. But what was discovered when the Austroads document was released, and really nobody had done safe system assessments in this form before the release of this document. As I said, there's some of us have been doing a slightly different thing, but this came out and there was a little bit of work done on, you know, how's this going to work? Let's practice it on a few projects. But then it got released, and then, you know, it got a bit of traction and people started doing these, and it was sort of discovered that there was some gaps in this document. There was some things that didn't quite work in practice. In theory, they were good, but in practice, they weren't so good. So a number of things sort of happened out of that. A couple of jurisdictions produced their own supplementary guidance, and so Victoria and South Australia produced these safe system assessment guideline documents. The documents, these two are pretty much the same, and it's clarified a lot of grey areas within Austroads, a few things that don't quite work, and provided further guidance. So we'll be sort of taking you through how to do a safe system assessment in accordance with Austroads, but also these ones. And then, as we showed you, we have filled in gaps that are still there within Austroads and these jurisdictions supplements for quite a number of specific things. So all of that documentation you've got, it's ready to go. It's all in the learning management system. But I'll take you through it, and you'll get some practice. And of course, like anything, the best way to learn it is just to get out and do one and get some feedback. And when you get to points where you're confused, look things up or get in contact, and we can talk you through it. So the first thing you do, really, after being engaged to do a safe system assessment or being asked to do that, is to gather intel about the project context. And Austroads produced these prompt questions. Now, they're not all the questions you might ask, but they certainly help you gather a nice broad understanding of the project. Now, what's the function of the road, the growth, freight movement, speed, amenities, what are the concerns, asset maintenance renewal, why is the project happening, what are you trying to achieve, what's the function of the road, what's the movement in place or one network framework categorization, lots of questions around speed and speed management and what's going to happen there, and what road users are there, elderly, children, we've got cyclists or not, is it on the strategic cycling corridor, what's the vehicle composition. So what I tend to do at a practical level is send these questions to the project team, usually sort of in a Word document with a table, and say, can you fill out as many answers as you can to these, and also maybe send us any documents you can with background information, if you've done planning studies, if you've done traffic modeling, if you've done anything else, and so you're gathering that intel and context and working that all out behind the scenes. So the assignment that you're going to do, we're not going to ask you to do this because this takes a fair bit of time. So that's one thing. The second is that some of you will get hypothetical scenarios. So there isn't any of this thinking done and documented. And some of you will get real ones, but we maybe don't have access to some of this. So for the purposes of just the training and the mock safe system assessment, you'll just do a, you won't be filling out any of this background context or the like. So you'll have to probably make some assumptions on quite a few things, but I think you'll be fine with that. So keep your questions coming in as we go. But what I'll do is show you now that I'm going to jump right to one of the end products, the things that you're going to produce. This is an output. That's a simplified output, but nonetheless, it is a sort of output. Let me explain it to you. What we're seeing here are different crash types in these clusters of bars. Run-off road, head-on, intersection, pedestrians, cyclists, and motorcyclists. And then this middle one being other, which is trying to cater for any crash type that hasn't been picked up there. I'll do it now actually. It's important for us to think about these as crash types, okay? So if you are somebody who's done crash reduction studies in the past and and deals with crash codes a lot, you'll be very comfortable with this because these are essentially that. But to be able to sort of think about these individual crashes, we need to think about things like, okay, if a pedestrian is walking across an intersection and they are struck in the intersection, crossing the intersection, is that an intersection crash or is that a pedestrian crash? Where do we put it? The answer to that is it's a pedestrian crash because it's the pedestrian that's going to be injured. If a vehicle, say, has run off the road at an intersection, is that a run-off road crash or an intersection crash? Well, if the injury is associated with running off the road and hitting a power pole or something like that, or a signal pedestal, that's a run-off road crash, even though it happened within an intersection. The intersection crash is vehicles striking each other. So I'll play that out a little bit more as we go forward. The next thing you see here is that lower scores are better. Okay, and this is safe system alignment score on the y-axis. So what we're seeing there in red is the existing conditions. Okay, so that's what's currently there. You've got no project. You go out to an intersection, for example, you look at what's currently there and you score it. Under all these crash types, what's the risk? What's the chance of this crash happening? Then you get their designs. And in this case, it looks like they've got a design for a roundabout at this intersection, a design for traffic signals with a modified T, and traffic signals with a conventional T. So they've got 3 different designs. And then you score each of the designs. So you say, right, okay, the roundabout. Well, how does it score for runoff road, for head-on, for intersection, blah, blah, blah. And then you do the same for the different traffic signals. And so you can start to see you build a picture of understanding risk by crash type or safe system alignment by crash type for different intersection forms here or project designs that have been produced. Okay, so that's the end product. So how do we get there? How do we get these numbers in there? And this is where we use the safe system assessment matrix, which is essentially just a table. I mean, it's a table, it's called a matrix, but it's a table. And you'll see that it's got 3 rows, and hopefully this is not a surprise to you that they are exposure, likelihood, and severity. And then the columns we see there are runoff road, head-on, intersection, other, pedestrian, cyclists, and motorcyclists. The crash types we just talked about. This other category is anything else that you can't fit into those others. So what usually comes up in other is railway level crossing crashes, so crashes with trains, sideswipe crashes, crashes with animals, rear end crashes. Now, I'm talking about crashes like that have happened, but this is all predicting. So you're going to imagine what could happen and then categorize it. And you say, well, people could definitely run off the road here. And that's thinking then into that runoff road category. Okay, so this is the matrix. And what we aim to do is put a score out of 4 in each cell of this matrix, in each square. And we want to go between 0 and 4 for each one. So let's go through these one at a time. Exposure. You can see here that exposure is for runoff road crashes is driven by AADT, the annual average daily traffic. That's how many cars and trucks are going through there. The runoff road head-on and intersection are associated with passenger vehicles. So what is the number of vehicles going through there? And say you've got a road that has 2,000 vehicles per day. Okay, we can't put 2,000 in there as a number because it isn't between R1 and 4, is it? Oh, sorry, R0 and 4. So what we have to do is go to a scoring reference sheet that sits in the Austroad Safe System Assessment Framework document. I've reproduced that here for you, and it's in the learning management system. It's in these notes, and it's in lots of places you'll find it. But you can see here they've got the score, and then we've got exposure, likelihood, and severity. So let's have a look there. We can see a 0, a 1, a 2, a 3, and a 4. Let's go like a 4. 4, remember, being the highest. But what are we seeing? Volumes of vehicles that might be involved in a particular crash type are very high. So the next little bit I'm just going to cross out because it doesn't actually play into this anymore. So that's a Victorian and South Australian decision made, and I'll explain that later. But anyway, just concentrate on very high. For run-off road, head-on, and other crash types, AADT is greater than 10,000 vehicles per day. Okay. For cyclists, pedestrians, and motorcyclists, volumes are greater than 100 units per day, which are crossing or walking on. So we said, what do we say? 2,000? Well, it's not more than 10,000. Let's go down one. Let's see if it's a 3. 3 is between 5,000 and 10,000 vehicles a day. Or when we get to pedestrians and cyclists, 50 to 100. Okay, no, 2, between 1,000 and 5,000. Okay, we found it. It's a 2. We go back here and we just simply put a 2 in there. Now, exposure is really quite clear cut, at least if you're given those traffic volumes. The AADT for head-on is going to be 2 as well because it's the same volume exposure, unless it was a one-way system, unless maybe you had a very big concrete rigid barrier down the center line, so there was no ability to get to a head-on, so we've got complete separation, then your exposure could be 0. Your AADT could be 0 in terms of exposed to that crash potential. I wouldn't put a 0 if it was a flexible barrier system, like a flexible W-beam or a flexible wire rope down the middle of the road. Now, the reason for that, it is incredibly effective, but it can be penetrated and vaulted, and there's certainly a lot of knowledge that larger vehicles could penetrate and the like. So what I'd do is still put my 2 in there, and I'd address its wonderful features in the likelihood and severity, but we'll get to that. Okay, so that's pretty nice. But we've got this 2,000 vehicles a day road, and now we get to an intersection. And you can see there it says AADT for each approach. So say we then come up to an intersection and it's also got 2,000 vehicles. So we add the 2. So we got 2,000 on this leg, 2,000 on that leg, we're at 4,000. Where does 4,000 sit in our scale? A 1, less than 1,000? No. Oh, it's still in the 2 category. Okay. Other, probably, depending on what you're looking at, going to be driven by that as well. So we're sort of seeing a theme across there. Then we get to pedestrians. And we say, well, how many pedestrians are exposed to these crashes? What's your annual average daily traffic of pedestrians? And this is interesting. my experience is when you ask project teams and the like, what's your traffic volume? They give you 20 years worth of traffic volume. There's so much data. You go, what's your pedestrian volume? You're like, oh. And, it's probably an indication of many, many things associated with transport. We won't get into that. If you are not provided with that data, they don't have the data, they haven't done pet counts, they haven't got that information, you need to make a judgment call. You can ask them their opinion. You will go out to the site, so you'll observe, you'll see, you'll go, okay, there's a lot of pedestrians here, or I've seen a pedestrian. This is a very rural area. There's nothing around. Not much. So you may have to make a judgment call on that. You'll make a judgment call and you'll sort of bring it back to things like, for this particular crash site, particularly low. Now, yes, we've got less than 10 units a day, but think about that particularly low. So let's say we're in a rural environment. Maybe there's the very occasional person who goes for their morning walk through this area, but there's not a lot there, so we might go 1 there. And cyclists, same thing. It's not a commuter road. It's out sort of in the middle of nowhere. We're going to go 1 there as well. And motorcyclists, sometimes you get data, often you don't. A good rule of thumb is 1% of AADT. You could maybe go up a bit if you're in a very popular motorcycle area. You might go up a little bit more, but let's go with 1% of AADT. So we put 2 in there as well. Because remember, motorcyclists sat in this motorcycle down here in the less than 10 units a day or the like. Okay, so we've got numbers put into our exposure category cells. So that's good. And that was fairly easy because it's all about numbers. Okay, so how many are we talking about? And reference that to the scoring sheet and put your number in. I'll pause shortly and take questions before I jump onto the likelihood scoring. Kathy.
Thanks, Ken. Easy, you say. Where have the ADT and PED cycle thresholds come from? Also, are the PED cycle thresholds one-way or two-way flows?
Very good question. Okay, where have they come from? So they've come from the Austroad Safe System Assessment Framework, and so CASA, MUAC and ARB, all these wonderful research organisations determined those thresholds, and I don't know the inner workings of it, but I do know that there's a lot of people questioning the applicability of those in certain scenarios. So there is a bit of work happening at the moment to check whether those are still appropriate or we need to tweak those and adjust them. But for now, that's what they are and that's what people use. And are they one-way or two-way? Well, they're two-way. They're two-way.
Thank you. Similar, are the AADT volumes for an intersection just the approach volumes on each leg, i.e. not including the departure flows, or two-way per leg, which would double count some flows?
Yeah, so just take the inflow of each leg there. Don't double count, if that makes sense. So think about individual exposed to a crash potential coming in. That's one. And, so how many you got on that leg? How many you got on that leg? How many you got on that leg? How many? Yeah, that's it.
Okay. Tell us about the subjectivity in the scoring. Is there, I guess it's not too hard to swing in the direction of bias?
So exposure is kind of hard to do that with. Likelihood is where there can be a lot of subjectivity come into it. But what I would say on that, and you'll see the subjectivity that comes into it next in likelihood. What I'd say to that though is that there's subjectivity to any risk assessment methodology, isn't there? Like you do a workplace health and safety risk assessment. There's a hell of a lot of subjectivity to that. And what do? You engage with people who are professionals at that, who understand the risk, who understand what's come out of these things, and they make a call on it. And you sort of have to respect their professional judgment and opinion. So we do get freaked out about subjectivity because there's numbers to it. If we were just sort of said high, medium, low, people wouldn't be as freaked out by it, I think, in terms of that subjectivity. That being said, the way that the safe system assessment framework is being used in some jurisdictions is pretty powerful, I suppose, and potentially puts too much weighting on the end numbers. So what we're currently doing with the Victorian government is setting up a far more rigid system to get a initial base level scoring. And then the assessors can adjust from that base level. But that we've got some pilots of that going, but we haven't quite got that. We're not quite happy with it yet, but yeah, it's trying to address exactly that concern. But some of you are probably not, it's not making sense to you yet because you haven't seen the likelihood, me explain the likelihood subjectivity of getting to that score.
I think we're good, Ken. Yep, you can carry on into likelihood.
Yeah, great. Just lost my clock, so I don't know how many hours in we are. Okay.
15. No, we're 35 minutes in.
I've got my phone now, so we're good. Okay, let's talk about this likelihood one. And we've already just established that this is quite subjective. But you don't get to just randomly pick a number that you want. You've got to justify your scoring. You've got to justify your scoring with dot points and with information in this cell. And so what you do is you say, right, I'm now thinking about what is the runoff road risk or chance that this will happen in this area. So you've taken the number of vehicles and pushed that away. Get that out of your mind now, because the number of vehicles has been accounted for in the AADT. What you're thinking now is for an individual, what is their relative likelihood, relative chance of running off the road and being involved in a crash? And I stress relative likelihood. I'll explain that shortly. But what are some factors that are influencing this? And you've practiced this already, but speed, geometry, shoulders, lighting, barriers, hazard offset, delineation, signs, line marking, etc. And there'll be many, many other things. So you've got to dot point these out. You're looking at an intersection, or you're looking at a length of road, and you're making notes on all these things and more. Then you go to your scoring reference sheet and you say, okay, what are we looking at here? Let's take a 2. What does a 2 say? It is unlikely that a given crash type will occur. Wow, okay, we're not given much help here at all, are we? Let's see what a 3 says. It's likely that a given crash type will occur. Oh my gosh, we got no help here. Okay, 4 looks better. There's more words here. The likelihood of individual road user error leading to crash is high, given the infrastructure in place, e.g. high approach speeds to a sharp curve, priority movement control, filtering right turn across several opposing lanes, high speed. Okay, so we've got a little bit more of a rounded feel for that. The reason I stressed relative likelihood is because if you took this on face value at an individual's likelihood of being involved in a runoff road crash at a certain point in is highly unlikely. Everything would be 1. So that's at a pure risk level or pure likelihood level. But if you do that relative to other areas across New Zealand, then you're in the position to be able to say, you know, okay, the speeds, the angles, and everything we know about that makes it highly likely, not likely, or the like. So what we did, because this is a real point of confusion, and it's the big one where you get swings in numbers, is we did put out a fact sheet on this to try to help in the interim before, you know, any tools come out. But this relies on you and your judgment and your, you know, understanding of the chance crashes happen, all of those factors that come into play. What I find is that people who are road safety auditors or have done lots of crash reduction studies tend to be really quite good at this likelihood understanding, putting the factors down and making a meaningful answer to that. Others sometimes take a little bit of time to calibrate that and get it right, but hopefully you'll be able to get an understanding. So let's, you know, say that our area's got, you know, we're doing this hypothetical road. It's got a 70 km/h speed limit. It's got sealed shoulders, audio tactile edge line. It's got lighting. It's got sealed shoulders. Surface is really quite good. What are we saying the chance relative is? Well, you know, 70 is reasonably up there in a speed, but it's not your 100. I've got these nice sealed shoulders and all these other good features. I think, you know, it's unlikely that a given crash type will occur because of all these wonderful features. If it was 100, it was on as a curve, there was adverse crossfall, there was, you know, no lighting, bad delineation. Oh, well, we're up around the 4s now. But we've got all these good features. So let's, you know, go back and we dot point all of these different things that we're noting. What are the good? What are the bad? And we come out with a 2. Now, you know, you go to head on. Okay, well, have we got separation there? You know, is there a wide center line, or do we have that barrier down the middle or not? I think I was using a hypothetical here that we have some sort of barrier down the middle. And so I'm going to say, well, what is that? I've got a barrier down the middle, and I know the barriers are test level 3, MASH test level 3 barriers. So I know it's been tested on a 2-ton pickup truck at 25 degrees at 100 kilometers an hour, but nothing bigger than that. Oh, geez, I'm scratching my head here. I really think it's pretty low chance that anybody's going to penetrate that. But there is still that chance. Am I going highly unlikely? Or do I want to go down here and say there's only minimal chance of a given crash will occur for individual road user error given the infrastructure? Only extreme driver behavior or substantial vehicle failure could lead to crash. Yeah, I'm really not comfortable quite to that, because I know if a larger vehicle makes a human error, just a normal mistake of falling asleep or being distracted, or, you know, having a heart issue or something like that, that they penetrate that system potentially. But geez, you know what? I'm going to go with 0.5. Now, I think this might be a question that's bouncing around in the chat at the moment, is how precise can we be? You can go to a 0.5 if you really must in, you know, these sorts of situations that I'm talking about now. Or if you're in a safe system assessment team and you come to the point where you absolutely can't agree between a 2 and a 3 or something like that, you go 2.5. You shouldn't, you know, do it all the time, but you can go to a 0.5 if you need. You can't go more precise than a 0.5 and a half unit. okay? We prefer you to stick to whole numbers, but if you must, you go to 0.5. And then we go and we do this for all of these things. So we look at the intersection. Is there a see-through effect? Is there good lighting? What is the intersection form? Is it give way? Is it for traffic signals? Is it, is there advanced warning of it? Do we know it's there? Are there sightline impediments for vehicles trying to exit? All these sorts of things. Well, how many conflict points? We've got lots of conflict points. There's a lot of confusion. And you come out with your score on that, whatever you decide, and so on and so forth. Pedestrians, you do the same. What are the pedestrian facilities? Is there a nice crossing there? Is it a raised crossing? Is it well lit? What's the speed of vehicles coming through there? And the like, and you end up with that. Now, a lot of the time, if I have a very low score here, so we're in a hypothetical here, imagining area that really doesn't have many pedestrians are like. Okay. Odds on there's not going to be good pedestrian facilities there, are there? Maybe there will be, but so it's got no crossings, it's got no footpaths, it's got no, lighting, people having to walk on the road shoulder and the like. The fact that nobody's walking there has already been accounted for. So we go with that for there. And you do the same for cyclists and motorcyclists, whatever. You've got to justify this. I'm not going to go through each one. Okay, so we've got some numbers there for that. Then you go to say, okay, we've established how many people are exposed to this crash. We've established the relative likelihood of crash for an individual. Now, how bad is this going to be? So, crash is now happening. We go into physics, biomechanics of injury, and crash types. And you can see here the factors. We've got speed. We've got some roadside features. Speed. Speed's a pretty important factor in the biomechanics of injury, as I think you're all getting the picture. Got impact angle on this one. Things like, what's the percentage of heavy vehicles for head-ons? Because if it's a head-on with a heavy vehicle, it's going to be worse than a head-on with a passenger vehicle. There may be other factors, like pedestrians, for example. Sometimes you might want to tweak up your pedestrian crash score because it's a lot more older people, okay, or young kids that are more vulnerable. So you're playing around with a bit of these sorts of things. Maybe the heavy vehicle stuff comes into play over here and here as well. But again, you dot point these out. Crash is happening. How bad is it going to be? Well, it's going to be influenced by these things. It's going to be influenced by these things. And then you go to your scoring reference sheet and you say, okay, let's have a look here. Let's go up to a 4, the worst. Should a crash occur, it is highly likely that it will result in fatality or serious injury to any road user involved. Kinetic energies, that's the biomechanics of injury. Kinetic energies are high enough to cause fatal serious injury, or KSI, or which some jurisdictions use KSI, crashes, and is unlikely that the forces will be dissipated before reaching the road user. So what does that mean? Well, that means things like running the energy out over time along a barrier, rather than abrupt energy transfer. But dissipate over time. Cushioning, angles. So this is where we're into that space. Okay, so that's highly likely. It is likely, unlikely. Okay, we're in the slightly subjective territory here, but with a bit of science behind it. And this is where I want you to be using the scoring thing as a start, help you think about it. General indication only, professional judgment required. It's there to help guide you a little bit, but you've got to have a think about all of this yourself. But let's have a think about that. What were we saying there? We had a 70 km/h speed zone, and we're thinking, well, okay, we've got runoff road crash. Now, we don't have any barriers on the roadside. We've got these nice sealed shoulders and edge line, but they're likelihood factors. The crash is now happening. Okay, we've got culverts, we've got lighting poles, we've got trees. Are the lighting poles frangible? Okay, the trees are there. What's the width? Okay, the trees are more than 200 mil wide, so they're not going to budge when struck by a car. So you're packing all of this thinking in, and you come over here and you say, okay, well, let's take runoff road. So pole tree impact is what I'm worried about, which would be rigid poles or trees. And I'm saying, well, 70, maybe they wash off a little bit of speed as they leave the road before they get to any of these hazards. But maybe the operational speed's a little bit higher. Okay, I'm going to go sort of somewhere between 70 and 60 maybe for that impact speed. And we take this and we come into here. And I'm sort of in that boundary there between a 3 and a 4. And then maybe I look at the site and I make some decisions and I say, well, actually, I think the speed management and speed compliance is pretty good, and the 85th percentile speed's a bit lower. So I'm actually going to go a 3 on that. Then you go into head on. You do the same thing. Okay, we've got head on now. And let's have a look where head on. Okay, I'm predominantly interested in car-to-car head on. And, I'm in there, and I'm really solidly in the 3 now for this one. So am I happy with that? Are there any other factors that I haven't considered to make my professional judgment? No, I'm okay with that. So maybe it gets a 3 also. And then you go through and you put all these scores in these. And of course, vulnerable road users, and we're talking about a speed of 70, and unless we've got sort of traffic calming features or things to slow down there, we're definitely going to be in the 4 category for those. Okay, so I'm starting to really make a mess of this slide, aren't I? Any questions coming in there now, Kathy, for me to deal with before I say or explain the fact that we've now got numbers in all these cells?
No questions, but are you trying to rub things out individually on that slide?
Yeah, I don't want to get rid of my numbers. I just wanted to clear out a little bit of space.
Okay. All right. Well, no, this is fun. Please ask questions, people.
Okay, let's go.
Yeah, fun. Exactly. Next. Okay.
Okay. So what we've done is we've populated this all with numbers, and I'm not going to, you have to spend some time. You have to spend some time getting your numbers that you're happy with. But then what you do is you multiply your numbers. You multiply down. Okay. So we go 2 times 2 is 4. And we go times 3. Well, okay, jump to the next page. 12. Oh, sorry. I keep hitting that next slide. So then we've got the next one, 2. Half is 1, 3, 1 to 3. So you can start to see that 16 and so on and so forth. So you're starting to see that you're able to produce this number, which presents safe system alignment for that crash time based on the exposure to it, the chance it's going to happen, and how bad it's going to be when it does happen. And then you can add all of these up to get one final score out of 448 if you want. So multiply down, add across. One number that I haven't been dealing with much yet is that 0, isn't it? Sort of ignored the 0 there. But a 0 comes about if you have no exposure. So for example, you have no intersection. You're just dealing with a mid-block section of road. There are no intersections. There is a 0 then to exposure to intersection crashes. And if you put a 0 here, it does not matter what the chance of crash is or the severity of crash because nobody is exposed to that. So if you were happy enough to say a concrete barrier separator there, a 0 and exposure to head-on crashes, you don't care what the likelihood of the severity is. Nobody's exposed to it. Likewise, if you could put a 0 into the chance of a crash happening, you wouldn't care how many people are exposed to it or the severity because no crashes will happen. But this one has to take into account a bit of, common sense reality. And it is almost never used as a 0 for the likelihood of crash. Because we know humans make mistakes all the time and there's that underlying individual risk always there. 0.5 maybe, but you're going to go really low on that. Then severity. If you're able to say, okay, when crashes happen, I'm very confident that they're not going to result in death or serious injury, then you can put a 0 in severity. And we don't actually care how many people are exposed to it and what's the likelihood of it, because when you multiply by that 0, it comes out to a 0. I do put a sort of disclaimer on that scenario. If you have 4 for exposure, 4 for likelihood, 0 for severity at an intersection, it's kind of like you're probably going to get a lot of bingles, minor fender benders and the like. And it's probably not a great thing for just operating a transport network. But from a safe system perspective, we're okay with that. We know crashes are still going to happen, but maybe just have a think about that. Okay, does that make sense, Kathy? No? Happy with it? What I'm going to do is I'll check in a second and see if there's any questions. But then I'm going to give you a little break, stretch, fill up coffee, water, and then I'm just going to walk through a bit of a live example. Again, a very scaled back, trimmed down, hypothetical version of it. And then we will introduce you to your exercise. Any questions there, Kathy?
Thank you. Thanks, Ken. If your site is not an intersection, do you leave that column blank?
Yeah. So if your site's not an intersection, they're simply going to put a 0 here, ADT 0, and then you can just leave those blank. I mean, it doesn't make any. It is nonsensical to write things in there.
Okay, good. An example I think will be good, but will we have a break first?
Have a break.
Okay.
5 minutes.
Break. 5 minutes. Thank you.
That is a yes. Recording is in progress. Okay, so we've filled out all of this. We've shown you how to put scores in it. We've had a little bit of a chat about some of the subjectivity to it, some of the more specific, rigid stuff to do. So let's do that little, I suppose, just example. So here's a sort of simplified one to make sure it fits all on one slide a bit. And don't worry about reading the details of it. I just want you to sort of see output. So you can see there's not too many words in the exposure bit because it's just saying, the volume of traffic is whatever, and thus it gets this score based on Austroads, and that's it. The likelihood, though, you see as things that increase make you want to put this score higher dot point, dot point, dot point, you know, speeds this, missing guideposts, confusing. Things that make you want to decrease it, this, and this. And then some sort of score there. And severity. So this one has a nice little reminder of what sort of speeds you can crash into roadside objects at. But again, what increases this score and what decreases this score? And some dot points and dot points. Score, final score. And so that's there for all of these different crash types, and you go through each one. So the first thing you do is the existing conditions. So you go out to whatever site you've got, maybe something like this. You've got an existing intersection and it's got a give way sign. And you can see there, it's sort of windy bit of road. It's got a footpath. It's got some power poles, some trees, got some line marking. Got some guideposts. Looks like it's got some lighting, a bit of lighting as well. It's got some other things around there. A culvert or drainage structure thing there. So, you know, you're gathering an idea and you'd watch how it operates and what people are there and using it and the like. And you then go back and you fill out this existing condition, just what you're seeing out there, what's existing now. And you fill all of this out. And you kind of did that with your existing intersection for your module 2 assignment and went through and you thought about bits and pieces. You can do a much bigger version of that. Then you get out the designs that they've given you and ask you to assess. And you say, okay, for this intersection that we were just looking at, okay, they've got an idea. They're saying maybe a roundabout. Here's a nice sort of level of design, enough that you can see what they're trying to do, but not so much that they're unwilling to budge because they've done 6 months worth of cross sections, long sections, drainage plans, lighting plans, pavement plans, signage, and then they really decided that's what they're doing. So it's nice. It's a nice level. So they've got this design. They've also got this design where they're saying, well, we're also thinking about this traffic signals on this modified P arrangement. And we're also thinking about this P intersection with, that's the plane on this approach and signalized here and the bits and pieces. Okay, so we've filled out this matrix and we've scored it for the existing condition. Then what we do is we grab this whole table, we copy it with everything in it, all the scores and all the words and everything. Copy it, we paste it, and then we manipulate it for the roundabout. We change it. We cross things out that have been removed when they build the roundabout. We add things in that are new when the roundabout comes, and they could be good things or bad things. We cross bits out, add new bits in, cross bits out, add new bits in. You do this. And anything we add in new, we like to put in a different color, red maybe. Any scores that change, we make them a different color. You go through and you do this, you change it all for the roundabout. So from existing conditions, it goes to this. Then you go and you get that existing conditions one again. You copy it, you paste it, and you do the same for every design that they give you. So now you look at this one and you cross things out. You cross different things out probably, and maybe add other things and cross other things out. And you do it again for the other intersection. And if they give you 50 different options that they've got for that intersection, you do 50 matrices, 50 of these tables. Then what you're able to do is produce an overall score if you want to, and most people absolutely do. And we're able to do things like say, well, the existing conditions of that site has a safe system alignment score of 118.5. The roundabout brings the score down to 90. The modified T brings it to 99. T intersection brings it to 105. So immediately, you're able to see with the designs that they produce, the best alignment with safe system principles at that site would be a roundabout, followed by this modified T and then this conventional T. But every one of them improves our alignment with safe system principles. This just does it the most. It's the best alignment. But none of those are 0. And so we can continue to do more of these to bring those scores further down. But you're able to then, produce scores, show people, the scores in different ways if you wanted, like this. But most people are looking to see this graph and they want to see where those scores have come from, what's driving those scores, where do we need to address things. So saying, okay, the roundabout seemed to come out best, but what do we got here? It's actually going to make things worse for cyclists. Gee, we're going to have to address that. And so for every one of these scores that you've produced, overall scores, every one of their options, you're going to make recommendations on how to get that score further down. And you're going to make recommendations, and they could be anything. You might say you should change the line marking here, or you might say you should add lighting, or you might say you should create a separated cycle facility, or do this. They're all just your suggestions, things for them to consider. But each one of those things that you say, you need to categorize as either primary or supporting. Now, a primary treatment is, as said there, road planning, design and management considerations that virtually eliminate the potential for fatal or serious injury occurring in association with foreseeable crash types. And you're doing it by sort of crash types. The supporting is road planning, management, design considerations that improve the overall level of safety, but not expected to virtually eliminate the potential for fatal and serious injury crashes occurring. Also doesn't change your ability to put a primary treatment in the future. That one's not used that much as a specific thing. But the idea really here is that with humans being humans and making mistakes and failure happening and all of these sort of things, to be a primary treatment, we really want to be seeing physical things that either remove the exposure completely, grade separations, pedestrian underpasses, big separators and the like, or we want to see things that mean that the energy is managed to within tolerable levels. So you really can't get to a primary treatment by just addressing the chance of a crash. So anything you've got in that you would categorize in like the likelihood factor is not enough to get you to primary treatment. Now, it can be very good, really good supporting treatments that really bring down the chance of the crash, but there's still that crash can happen. So for primary treatments, we're really talking about those things like roundabouts for passenger vehicle to passenger vehicle crashes, raised platforms, raised pedestrian crossings, separated bike facilities, these sorts of things. And when at the end or shortly, Kathy and I will show you in the Safe System Assessment Framework that there's lots of treatments listed, whether they're primary or supporting, to help you help you get your head around this thinking. So you'll be able to look at that and go, okay, and I get this, I understand this a bit more. Okay, so before I go to that, I've put non-safe system in there for terminology purposes. You really wouldn't be suggesting things that are non-safe system that make things worse. Okay, so we've scored we've done all this scoring, we've got our scores, we've got our graphs, we've made suggestions on what could be improved in all of those designs. Then we've categorized each of our suggestions and said, well, that's a primary treatment, that's a supporting. Don't get confused with the term primary, meaning it's like it's your number one. You might have 4 primary treatments and no supporting treatments. Or you might have 0 primary treatments and 4 supporting treatments. And that's okay. It's not wrong. It's just a categorization of that treatment's sort of effectiveness, if that makes sense. The other thing that's part of a full safe system assessment is to qualitatively answer these prompt questions. So we're not going to put numbers to these. We're just writing comments, putting dot points, thoughts, ideas down next to each of these questions. These, again, have come from the Australian Safe System Assessment Framework. And they're in the categories of road user, vehicle, post-crash care. Now, these may influence suggestions to the project team of what they could improve, or it may influence your scoring. Or you might go, this makes no sense, this question, in the context of the project I'm looking at. And that's okay, you just write not applicable. Let's just go through these very quickly. Are road users likely to be alert and compliant? And are there factors that might influence this? Have a think about that. You dot point things down. What are the expected compliance and enforcement levels? Drugs, alcohol, road rules, driving hours. What's the likelihood of driver fatigue? You know, is this in the middle of nowhere, between a couple of hours between cities, or is it in an urban environment? We've got lots of stimuli there. Can enforcement be conducted safely? That's an interesting one. So you look at their design and you say, oh, gee, okay, I'm not sure how enforcement would work. Maybe you talk to the local highway patrol and you say, well, here's the plan. What enforcement activities will you be able to do there? And there's some wonderful, amazing examples. One in particular that came about was a big $103 million duplication of a road, and it was going to get continuous barrier systems, and there was a safe system assessment done, and they sat down with the local highway patrol and they said, well, this is the plan, and talked them through it and said, you know, how are you going to go enforcing? And they're like, oh, it's going to make it really hard for us to pull people over. And we occasionally like to put the booze bus out in that area, and I don't know how we'd do that there. And then, we looked around and there was an area, it was an old stack site where they used to pile aggregate and things like that for roadworks. And it was, I said, oh, what about this area? Can you do something there? I said, oh yeah, that's interesting. And they said, well, some slight configurations, some barrier changes, some openings, some swept path to check things could happen, a little bit of sealing in that area. And a little bit further up, one of the maintenance gaps in the barrier was just adjusted and tweaked a little bit. And all of a sudden what they had, and what was ended up sort of being built, was an area where they could put their number plate recognition vehicle up the road. And they had a purpose-built, basically, enforcement area where they put the booze bus. So cars would go past, the number plate recognition vehicle would, grab their number plate, see if they've, got, if their car's registered. Well, they also check, are there outstanding warrants on this person and those sort of things. But from a road safety perspective, is it registered and that? But they can also flag any vehicles they want in for a a breathalyzer, and they've got this dedicated area, and it's actually protected. Their workers are safe. It's just wonderful, right? And that's all really because somebody was questioning there. Well, is there things that could be done here in this $103 million project to help with these other elements of the safe system? So I think it's exciting that that sort of stuff can happen. I've got other examples, but I won't. I'll keep moving on. Other special road users, entertainment precinct, elderly, on-road activities, motorcycle route, and the like. What's the level of alignment with the ideals of safer vehicles? Now, this is one of the questions that most of the time and very often at an intersection level or a length of road level, you sort of just go, not much I can say on this. But if you do a whole safe system assessment on a remote community or a mine site or something like that, then all of a sudden this can get a lot of meat, a lot of traction, and you can have a lot of thinking around it. What other factors that might attract a large number of unsafe vehicles? Is the percentage of heavy vehicles too high? Are there resources to detect non-roadworthy, overloaded, unregistered vehicles? Can enforcement of those activities be conducted safely, like weighing vehicles and those sorts of things? Has vehicle breakdown been catered for? And then we go into the post-crash care. Are there issues that might influence safe and efficient post-crash care in the event of a severe injury? Congestion, access, stopping space. This often plays out in motorways and the like. Do emergency and medical services operate as efficiently and rapidly as possible? So one of these, these are questions that sometimes bring about things like construction of helicopter landing pads in remote mountainous areas in order to extract injured parties, motorcycle riders or others. And then there was some of that was done in New Zealand. Different thinking outside of simply pouring concrete and rolling out roads and barriers and bike paths and those sort of things. Are other road users' emergency response teams protected during the crash event? Are drivers provided correct information? Is there reliable information via radio, BMS? And is there provision for e-safety? So this is a bit of a question of the future. And so that's sort of things like cooperative ITS and vehicle to infrastructure technology, roads that cars can read. Now, again, a lot of this stuff, if you're doing a brand new tunnel or something like that, or a major new motorway that's going to be heavily used for the next 50 years, and you'll be thinking about those integrated transport systems and those sorts of technology systems and the like, and you'd probably have to get expert advice to input into that. So a lot of the times for our just little assessments on individual smaller projects, you don't really write anything in there, but it's good that the questions are being asked. Okay, anything for me to deal with, Kathy, before I sort of explain what would be in a safe system assessment report?
Thank you, Ken. There was a question about your example earlier about why the modified T option has a lower score for intersection crashes than the standard T option. Hugo's jumped in and said it looks like the severity is higher for the standard T because of the straighter alignment on the east-west movement. Is that correct?
It is. Yes. I really got
yes, but yes.
That is correct. Like that is correct in theory. That assessment has been sort of stripped back a bit to try to make it good for this. It's these assessments can be fairly meaty and have a lot of thinking and a lot more to it. But essentially, yes, that's right. A straight approach rather than the curved nature of it.
Thank you. And are we to consider cost in these?
No. Cost isn't our concern that's a project manager's concern. But that being said, when you come out with your recommendations, you want to push them but you don't want to be ridiculous. Like if you're suggesting grade separation of local streets everywhere and that, and yes, you're going to get perfect alignment with safe system principles, but it's not going to happen. So you want to be calibrated at a bit, but I don't want people going, I'll never put that in. Or, where you go, well, they'd have to push it a little bit to get a little bit more money, but that'd be a wonderful outcome. I'd like to see that in there and then let them justify not doing it rather than us making assumptions that they couldn't get another 20% or 50% on their project. So you've got to sort of make that call. What's pushing and getting us better alignment with safe system principles, and what's just, absolutely impossible, never, ever going to happen.
Okay, good. How many, when you mentioned earlier, 50 different design options, how many design options have you done?
Not 50. I think we had one with 11 design options, which I think is the most, and that one's, yeah. There is, and I have been in part of a big safe system assessment team on a massive project that had well over 50 matrices produced. And that wasn't because there were 50 design options, but what you'll discover is if you do a big project, this one was a new toll road, like 20 kilometers new toll road, you have to break that up. You can't just do one matrix for that whole thing. You've got to actually do matrices for each interchange and each, connecting road and connecting bit of thing, because, you just lose all of the detail and specifics and value if you were to just go one matrix. It just wouldn't make sense.
Okay, I think that's it for now. Where are we at?
So we want consistency in the reporting, and this has kind of been covered by the Victorian government nicely, in the sense that they issued template safe system assessment reports for us to use, and they've put all these things in it. It's good. It talks about what type of assessment you're doing, lists the team members, inspections, project background, context, your matrices for all of the design options, commentary, and the like. So what we're going to do is, for your assignment, we're going to give you one of the matrices, one of the templates, get you to use it. Now, the Victorian government has clearly said, please feel free to rebrand this, put your own branding on it, change the colors and everything like that. What we just want is that everybody uses the same headings and the same sections, and we have consistent reporting across industry for safe system assessments. So if you do them in the future, you can use these templates and adapt them so they're your own. And so what we're going to give you for your assignment, safe system assessment, you'll see that we've got in there and we've highlighted areas that we want you to fill out. And you'll see later that we've crossed out some areas that we don't want you to spend time on. Because what we tried to do is really narrow this down to just the key things that show that you understand how to do a safe system assessment. We didn't want you writing background, doing lots of, all of this extra work that really we're going, it's not showing us that you know how to do a safe system assessment, it's showing us that you can sort of know how to write a report, I suppose. And, we want good reports, but that's not the purpose of this course, really. So we're going to give you that site, and we pointed you at those sites last session, but we'll point you at those again. And you've got an actual site near your home or your office or whatever address you gave us. You'll get a design for that. But remember, the first thing you'll do is you'll look at it, what is currently there, to score that. And then you'll look at the design and say, okay, you're going to change it to that. Now, what would it score? And what can I change in this design to make it even better? Not what can I change in the existing conditions, what can I change in their design? So we're asking you to go to a site, and we've selected the sites to be close to you, but also to be low risk from a occupational health and safety perspective, to ensure that you can do this very safely. You don't have to stand on the road to do it. There's safe places to park away, and really what you're doing is just observing. How does it operate? What are the different features out there? How's it going to tie in with this new design? Those sort of things. You don't need to measure lane widths. You don't need to look at drainage crossfall specifics and those sort of things. Stay back, stay safe there. Don't go on the road and do anything out there. Just cross at appropriate points. Wear your high-vis vest. Don't be a hazard to others. So don't make people walk around you on the road, or don't park in a spot that you block sight lines or make cyclists drive into the road. Ride into high-speed traffic lanes or anything. And we have got a safe work method statement that Kathy will show you shortly that you have to sort of agree to. You have to click, yep, I'm going to follow this. And it's very simple and it's very logical and common sense. And it says things like, I'm not going to go to this site intoxicated. I'm going to, I understand I've got a responsibility for my safety as well as that this has been checked and the like. I'm going to wear my high-vis vest. I'm not going to drive for 10 hours to get to this site straight without resting. And of course, if your site was 10 hours away, you just get in contact and tell us, and we will give you a site that is not 10 hours away from you. So yeah, you're going to be required to have a look at that. Okay, Kathy, I think it's best if we just do this live in the learning management system. I do see there's a question in there about the difference between a full and a rapid safe system assessment, and that is discussed in detail in the last module in a week's time.
Oh, doing well. Okay. So this is in module 4, which I'll show you when it works for me. But here is the template that is provided for you. And as mentioned, you only complete the highlighted sections. So everything that's crossed out, you don't need to do. Make it nice and easy for you. Here's a highlighted bit. Ken, what do you do here?
I think you put your name in, but the important thing also is that a few people may have multiple people at that same site. And if you happen to know the person or want to go there and do this as a team, we're okay with that if it works out. But what we do want then is both of your names in that part. So when I assess them, I go, okay, this person, they work together on this. That's why they're exactly the same, not that one copied the other. So if, as I say, if there's multiple people doing the same one and producing the same report, multiple names in there, please. Excellent. Yeah, none of that project background stuff. But we've sort of left it there so you'd see what, if you're doing a proper one, you'd fill out all of this and expand it all out. Proposed works, we just want you to put a very brief little explanation of what the design is, what they're planning to do. So you're going to look at this design, you're going to, okay, then building a new roundabout, here is the plan. And you could even put a snip of the design in there. That would really help and save you having to write words. I don't want pages and pages of text here about background of this. Very just short, concise. You might put in a real one, you might put a lot more information in there, but not for this. This next highlighted bit in the assessment summary, you'd write at the end after you've done all your scoring. And the next table, to put scores in, you're going to have to do the scoring, and to produce a graph, you're going to have to do scoring. So you're going to have to jump down to your matrices, which will be the next page. And there it is, the existing conditions And you can see there that we've got exposure, likelihood, severity, and within each of those, you'll be putting dot points under factors that increase the likelihood, factors that decrease the likelihood, putting speed limit high, operational speed looks high, there's adverse crossfall, whatever you've discovered out there. For the existing conditions, what's there? You go through and you put all of that information in there and you make yourself happy with that. And then you go, okay, let's have a look at this design. Let's copy that whole table.
Actually, yeah, sorry, I'm just going to bring up. So this is an example of a design.
Yes. Okay, so good, thank you. And it is a roundabout that they're proposing there. So the first thing you'll be doing though is looking at what's there without that roundabout and scoring it. But you do have some hypothetical traffic volumes. They are for training purposes. They have been completely made up. However, we want you to use those so we know that you're able to go, okay, 3,000, that's a score of 2, or okay, 3,000 plus 2,300 plus this plus that, and that gets me a score of 3. And cyclists 5, okay, that's a score of 1. Actually, I better not do this for all of this. This person will be just taking all the answers. And so you filled all of that out. Copy it. And oh, look at that. There we go. We've got a nice new matrix. It's got everything filled out. And then you go design option. And you're only given one design option for this exercise. Tempted to give you those 50 that we talked about. So you'd have to do 50 of these. But no, we want to keep it nice and streamlined. You have one design option. You go through all of those things that you've written for the existing conditions and you go, that's not there anymore. So you highlight it and you go strike through. And then there's something new that appears and you go, right, that's new. I'm going to make that red and add that in. Or, you type it in and you make it red or whatever, or another color. And then you change the score. Okay, we better make that a different color. So the person reading this knows those are the scores that are changing. That's where we're influencing things. And so you do that for that design as it's proposed there. And then we get you to come up with some ideas to improve the design. So if there's that roundabout we saw and you go, oh, well, I think the approach speeds are going to be way too fast and they've increased the likelihood of this and whatever it is. And I want speed calming on the approach to it. I want to put some speed cushions on the approach, for example. And then you'd say, well, that's a primary treatment because we're addressing the speed and the entry and it brings it within tolerable levels. And so you'd write that in there. You don't fill out the project response because it's not your project. You're just advising on the project, assessing it. Let them respond. So that, you might say speed cushions and they might come back and say, we like your idea, but we don't use speed cushions for these reasons. So instead, we're going to do a speed table at this location. You go, cool, right, good on you. Don't worry about filling out a conclusion. Put in some support, primary treatments, supporting treatments if you've got them, or give us a few. Show that you understand how we can push projects to get better alignment with safe system principles, and categorize them into that, which table they go into. And how do you do that? Well, here is the Safe System Assessment Framework, and you can see there on page 19 or whatever it is, that the tables start to appear and they're by crash type. So that's runoff road crashes. And the green there are primary treatments, flexible roadside barrier in there. So it even shows you how is that influencing it. Severity, exposure, or likelihood. You'll see each of those have a severity element because they're primary and you kind of got to have severity element addressed. The next one, the yellow and the orange there, they're both supporting. You kind of want to think about them as one. There used to be this little use of a step towards treatment, and it just confused everybody. And so anyway, most jurisdictions just use primary and supporting now. And so you've got lots of those listed there. And you can see lots of those are just likelihood influences, aren't they? Some of them are severity as well, but likelihood. And, it's got that for lots of crash types. There's head-on one, and then we'll see intersections, and we'll see. These will give you some ideas, some thoughts, help you categorize. They're not everything, though. Okay, they're just some ideas. You may come up with things that are outside that, and you make a judgment call as to how they sit. Okay, so you fill in a few ideas in there. And the only photo we want, is a selfie or a photo showing you on the site in your high-vis vest to prove to us that you actually went there. It's sort of our course requirement to ensure that people understand that you can gather a bit from the site, you can understand it. We want people to go to a site, practically do this exercise. So just put that picture of you on site in your high-vis vest in there. Okay. So what else have we got there, Kathy? Errors in your errors in the learning management system. So there is a little quiz, I think.
I'm in the wrong group. It's okay.
You're in the wrong group.
I should be in the May group, not the July group. I'm ahead of myself. So there is a quiz. Yes, there is a quiz. And everybody's looking at what's hidden from students now, which is the podcast, Should Traffic Lights Be Banned? So I will unhide that one so you can listen to that one. I made my kids listen to that. They loved it. So there is the template. Here is also this fabulous graph generator. So whoopsies, there we go. Hold on. Hello, Excel. There we go. So yes, generate a graph for you. You don't even have to do it.
Yeah, so I'm sure everybody in this group is able to generate a graph themselves. However, again, to try to streamline this, you can just pop the numbers that you decide in there, and hey presto, the graph comes out. You've got a spot there for the design, the existing conditions and the design, and you spit it out there. Feel free to use that as much as you want, whenever you want in future as well. I mean, it's very simplistic, but then you just either snip that with the old snipping tool, or copy it and paste it, and that's how you can easily produce a graph, which is a required thing in the Safe System Assessment framework. We need to see a graph.
Okay. Do we have some questions?
Back in the learning management system there, you would have seen, so there's everybody's sites, which is cool. So you find your name, you have a look at it, and you've got the site there. But if you go back to, when's it due?
So it's due in 2 weeks' time. So the idea is that you get out and have a look at your site in the next week. So our next session and our last session is next Friday morning. So between now and next Friday, you have a look at what you've got, get out and do your existing site visit. And then you can come back in the next session and ask any questions, because if you've got some questions about it, probably other people have the same questions. So bring along your questions, and we've got some time for that in our last session, but then it's due a week after that. So 17th of June.
Yep, good.
Do we have some, is that a real background on I like it. Yeah, I wish it was a real background on Ken's. It's the vision of our new office, isn't it, Ken?
This is Camberwell office. If it ever happens, it's not quite looking like this. It was.
It's got no staff too, so that's a problem, isn't it?
That solves a lot of problems, actually.
All right. Any other questions? Did somebody have their hand up?
If you just jump back one there, Kathy, you just want to point at the safe work method statement in there as well, just to show people where that is, so people. Yeah, so the safe working method statement itself is a PDF which you can open up and just see that we've had a look at your site and we've risk assessed, and you've got to make sure you're doing safe things out there, and then there's a one question quiz to say, yep, had a look at it, promise to follow that and not be reckless and like. There it is. Okay, I think people are.
Any other questions? Get in touch with us throughout the week if you do have any questions. Or it looks like everybody's site is okay for them. It's not a 10-hour drive like you suggested, Ken. We have a very good system that hopefully means it's maximum 15 minutes. And yeah, I don't know.
If you open up your site and download this and have a look at it all and just go, I don't understand what I have to do here, or I just don't understand this whole filling things out and numbers and it's all too confusing, just get in contact with us. We don't want you feeling overwhelmed and scared by this. We just want you to go through the process and we'll coach you through it. We've got people available to have one-on-one Zoom catch-ups with you if you need to explain things, or just quick email with your question or the like, and we'll certainly help you along your way. But otherwise, why don't you spend the next 15 minutes getting started?
What a lovely plan, Ken. Thanks for that.
All right. Have a good weekend, everybody.
Have a good weekend. See ya. Bye.